Yo, what's up, guys? Welcome back to CCT, a relaxing show about coding. Alright, so today I have the ability to draw stuff out. Yay. Let's take a look. I'm gonna draw things now. Hello, whoops. I got one of those fancy little pens. It's actually pretty cheap. Hello world. I did not go out and buy a tablet. I just bought one of those little drawing boards. And it might take me a little bit to get used to. That's okay. Undo. Okay. Put that pen back for now. Alright, let's go to the random question of the day. Wow, this one has a 50% acceptance. Let's see if I can do it. Okay, given two binary trees, write a function to check if they are the same or not. Okay. So, I think this is worth drawing out. I think, so there are, if I remember correctly, there are three ways, hold on, where's the, yeah. There are three ways to go through a graph. So if we have 5 and then most of 3 or something, and 8 and 4 and 6 and 9. Okay, so actually wait, could I want to erase this? I don't want it to be a 3, I want it to be a 2. Okay. And then a third. Oh, wait, I could have gone lower. Oh, well. Okay, so there are a few ways you can traverse a tree. There is, now I hope I get this right. There is, well, let me just say, there's pre-order, post-order, and in order. I'm pretty sure in order is basically in order, so it's going to be lowest to highest. It should be, so like 1, 2, 4, 5, 6, 8, whoops, 9. And what you do for that is in order is going to be go left, then do something, then go right. Okay. Sorry for my handwriting. So it's basically recursively going to go all the way left. And then once it can't go left anymore, it's going to do something. So do something at 1, sorry. And after it does something, well, wait. I guess we forgot. It's going to go past it. See that there's nothing there, so that's when left is over. Then it does something to 1. Then it goes right, see that there's nothing there. Okay, so now what do we do? So we pop back to 2. 2 just finished its go left, and now 2 is going to do something. We could print it out or something. And then, after 2 does something, then it goes to the right. Okay, and now 4 is going to go left, nothing. Do something, so like print out 4. Go right, nothing. So pop back to the 2. The 2 now just finished its go right cycle, so it is done. So then we pop back to 5, which has finished its go left cycle. So now 5 is going to do something like print out, and then we're going to go to the right side of 5. Okay, then we go to 8. 8, okay, so after we went to the right of 5, now we go to 8, and then 8 is going to go to the left as much as it can. So just to give you some intuition why this works, you go left all the way, because when you go to the left, it's always less than. So you go to the smallest number by going all the way to the left, Then you do something. You do something at 1. Then, then after you go all the way to the left, like let's say we're at 2. We want to go all the way to the left and do that. Then we want to print 2. And we want to print out 2 before we go to the right side because 2 is going to be less than the right side. So that's why it's left side, print out left side, print out yours, then print out right side. Okay, and all of these as a whole are going to be less than this, 5 here, and yeah, so 5 is going to like complete its left side printing out, which is all less than it, then 5, then do that. Alright. Let's see how much I can undo here. All of these things. Nope, not that much. Put right back. Oh wait, yeah, I kind of do want to. Well, I'll read it. So then, I mean, we don't need to, we only need to do one of these, right? So if we have 2 things, 2 trees, 2, 1, 4, 8, 6, 9. What we can do is we could go left. We could follow this same recursive pattern on both of them. And where we do something, we should be we could be comparing comparing values, and if they're not equal we return false, and if they're equal we just continue. Okay, so let's get back to the coding part of this. So we have 2 roots, so that's pointing to like this tree and that tree. Okay, so we do want to do this, well, yeah, let's do it recursively. So, can I just call the same thing? Maybe. Right. If P, so if P is null, so like not P, that's the cute way of writing it, then return true. Wait, no, they have to both end at the same time. So if not P and not Q, so they both are null, we return that. Else, if they are, one of them is true and the other is false, that means one of them ended before the other one. So we should return false. And then else if just the other way around, also return false. And in the final case, when they're both not null, we are going to be recursing through them to make sure that they're equal. So, okay, so let's say, I'm going to break this up. So, auto, Q, right, actually, yeah. I don't know if this is necessary, probably not. Oh yeah, okay. We could also say here, if P val does not equal Q val, this is another place to return false. Okay, so let's say they equal each other and they're both like not null. So then we are going to return, so they equal each other here. So let's return is same tree. We want to make sure the left side and the right side are the same tree. So left Q left, and is same tree Q right. Oh wait, I want to keep this consistent. P right and Q right. Okay, let's think about this. Okay, so if they are ever different values, we are automatically going to return false. And so if they are the same values, then we take the recursive leap of faith, which is asking, is the left of these trees the same, and is the right of these trees the same? So this is catching if they're not in the same form, like they're not symmetric, like this. Something that's not symmetric would be like this. You see, they're just not even symmetric. And then this one is like kind of, and then like if they are symmetric, all their values have to be the same. Okay. So I think this is good. Let's give it a run. Okay, last a good time. And there we go, guys. So that is how you can do this. You could also oh yeah, so I guess what I did actually, I did not do this, like I said. I actually did pre-order. It doesn't really matter, so I did my do something. And then I did something on the left side, and then I did something on the right side. This is pre-order. It really doesn't matter for this question. You see, I did something, and then like with the actual value, and then I went left, and then I went right. It's in this one, it doesn't really matter. Just some like facts. Post order you could use is pretty good for deleting stuff. Post order is I'm pretty sure it's left, right, and then do something. So you go all the way left and all the way right, so we're like here. So let's see, you go to 1, then you go to 4, you go to 1, 4, and then 2. This is good for deleting nodes. You see how you go like all the way to 1, left, 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 left. There. Then you go back up here. 2 just did its left. 2 just did that. So now 2 is going to go to its right call right here. And so it goes here. And then 4 is also outputted. And then, or we could do something with 4. We could delete 4. And then we pop back to 2. So after we deleted all of 2's children, we can delete this parent. And then the same process continues, you know. Yeah, so that is, so you could do this in any order. And yeah, that's about it. I'll play you guys out. Alright, this is Joshua Siegel signing out for CCT. Hope you enjoyed this, and I'll see you again for another casual code talk. See ya.